Okay, you guys grab your PowerPoints and we will move on. Just a reminder that Tuesday next week, we're going to be dissecting sheep brains in here. So make sure you kind of come prepped and ready for that. It's really fun. I think you'll enjoy it. And it'll be lots of fun. So go ahead and grab your PowerPoint. Also, I want you guys to turn in your books to section 6.3. It's on page. I can get there myself. Starts on 207. Okay, so we're going to talk about today different parts of the brain itself. So we're talking about specifically the central nervous system and then the spinal cord as well. Next, let's see, Thursday. Yeah, next week we'll get to 6.4 and 6.5. But let's talk about this, and you guys are welcome to grab. I've got this little. I've got this brain is the one I'm going to use today to kind of talk to you guys and show you guys. So y'all are welcome to get this out from wherever and look at it or kind of go through it as we continue on today. So let's get moving there. I would suggest that you guys take some notes today. I'll show you my notes look like this. So either take notes while I'm talking or listen to the lecture and then go home and read this section and take some notes. You guys know I'm all about the note taking, so go home. We've talked about this. We've talked about the other chapters. Read them, and then we'll go over, you can take notes that way if you want to. So let's talk about the different parts of the brain. First of all, the brain is about between 2.25 to 3.25 pounds. Okay, so not a whole lot of the percentage of your body weight. Approximately 100 billion neurons. 100 billion neurons. Remember, neurons are the cells that actually carry the nervous impulse. And then there's even more glial cells than that. Remember, the glial cells are the ones that support the nervous system. And so we're talking lots and lots of tissue, and I go from there. Okay, so the brain, cerebrum, diencephalon, brainstem, and cerebellum. These are the main kind of regions of your brain itself. The meninges are the layers around the brain. You'll probably recognize that from like meningitis. You guys had taken a meningitis shot. That's what that's related to, is the layers, like the covering around the brain that protects it. All right, so let's start with the cerebrum. This is what you typically think of as your brain, right? It's like the squiggly part of your brain that you see. So let's look at these. Okay, you got two cerebral hemispheres. Remember, hemi means half. So if you're looking at the brain, right, you've got a right and a left. Okay. The cerebral cortex is the outside. Anytime you see that word cortex, like we'll talk about the adrenal cortex, talk about the cortical portion of the kidneys, it's always on the outside. Okay, so when you're thinking that through, think outside. So if I open up this, you can't really tell on these because it actually like loops in from here, but there's a good picture. Maybe there's not a good picture. Kind of on 209. I don't know if it kind of makes sense, but the cortex is just the outer kind of edge of the outer surface of the brain. So it's got a few things, a few landmarks you'll notice. Okay, gyrus is like the raised area. So when you're looking at the brain, okay, and you see all these kind of like squiggly sections, okay, the gyri is plural for that. Gyri are like the raised sections that you see, okay? Sulci, okay, or a sulcus is the singular term for that. that is the actual groove in between the gyri. Okay. So those are the two. You might want to study those two together so you don't get them mixed up. Okay? A fissure is a very deep groove that actually usually separates regions. So you've got one large fissure right down the middle. You've got fissures between different sections of the brain. So like the longitudinal fissure, you can see on page 208. If you turn it over to there, you can see what it's talking about. Okay. So that is those major sulci are around like in similar patterns in humans, and you can see those, like the lateral sulcus is right where the temporal lobe hits, and what else? You got the central sulcus. That's one that goes right down the center. It's on the bottom of page 208. You can see it there. All right. The other thing to note about the cerebral cortex is that it's non-myelinated gray matter. We'll talk about the different types of matter, but specifically non-myelinated. You remember us talking about, we talked about in the central nervous system, those oligodendrocytes that kind of wrap around the axons of the neurons. Well, that wrapping is what makes up the myelin sheath. Well, these particular neurons in the cerebral cortex are non-myelinated. Okay? So they don't have that myelin. They're not supposed to. All right. Now, couple other things to know about the cerebrum. Okay? The right cerebrum basically controls the left side of the body. Left cerebrum controls the right side of the body. They have a kind of a crisscross that they do. So that's something important to note as well. That's why they usually say left-handed people are right-brained, right-handed people are left-brained. That's kind of why that saying is there. All right, so let's look at the different lobes, and you can specifically see these on the bottom of page 208. Not that one. Bottom of page 208, there's a great picture of the different lobes of the brain. And basically, these are just regions, and this is just the cerebellum is what we're talking about. The cerebellum itself is what that's what we're talking about, those regions. So, lobes. How do you want to say that? So the frontal lobe, these coincide with the bones. So that's one reason we do the skeleton first, right? We learn the cranial bones. So frontal lobe, okay, is where like your frontal bone is, okay, right up here at your forehead. Okay, parietal is right back here, right? It's kind of like top middle section, just like your parietal bone we talked about with the cranium again. Occipital is at the back, okay? Now, let me show you something. People always get this mixed up. Okay, hopefully you guys can see this. This little part down here that has all the lines in it and kind of looks like cauliflower on this side, okay, that is a completely different part of the brain. That's not part of the cerebellum. That's not part of the cerebrum. It's called the cerebellum, okay? So the occipital lobe is just in the cerebrum, which is the part with like the big squiggly line. So that's this section right back here. Okay, it's your occipital lobe, it's on the back of your head. Then the temporal, again, goes right along with your temporal bone. Okay, it's kind of on the side, right above your ears. That's where your temporal lobe is. So the frontal contains your primary motor cortex. Okay, so remember, motor, move, muscles, right? So that's the part of your brain that says, hey, it's time to move. Okay, sends impulses to your skeletal muscles for movement. Page 209, I want you to kind of bring this to your attention. So right in front of the central sulcus, okay, so in the motor cortex, it's in the frontal part of your brain. This kind of tells you, it goes down the way that this picture, I know this picture is kind of odd looking picture, but basically what they've done is they've taken, let me stop this for a second, and I'll make this a little bigger. So basically what they're showing is like if they were to take out a slice like this, okay? Slice of your brain. That's what they're showing you right here in this, on the picture in your book. So if they were to take out, so it's the primary motor cortex, which is right in front of the central sulcus, kind of at the back of the frontal lobe of the cerebrum, okay? You've got knee, toes on the inside here, hip, trunk, shoulder, arm, elbow, wrist, hand, fingers, thumb, neck, brow, face, lips, jaw, tongue, swallowing. So it just goes along the edges. Okay, that's what that is. That's what this picture is supposed to represent. And if you look at the little picture right above it, it kind of tells you where this is found. You'll notice the biggest sections, right, are fingers, thumb, face. This is made to kind of show you what has the most motor, which makes sense, right? Our fingers, we need to have lots of neurons that go to our fingers to make them move, because that's our fine motor movement. So the places that have fine motor movement are going to be the ones that have the largest portion devoted to them. So face and lips, fingers, those are all examples of that. So I know that picture is kind of weird looking, but that's what it's trying to tell you. Okay. Left frontal lobe, one thing that's located in your left frontal lobe is called Broca's area, which is your tongue and lip movements that have to do with speech. So I'll tell you why that's important. You have different areas of your brain that do different things. Some have to do with language, right? So you misunderstand or you have trouble putting what you're thinking into your language. Some areas, like Broca's area, okay, for example, this is specific to the movements of the tongue and lips. And so sometimes when people have a stroke, depending on what part of the brain it affects, it might affect just that thing. So for example, if it affected Broca's area, they might be able to think about what they're trying to say and even come up with good words in their head. But when they try to talk about it out of their mouth, it's like they can't make the words out. And that's because that particular area was damaged. Maybe not the area that actually comes up with words. Or maybe it was a different area that actually like puts thoughts into words. And so whenever they speak fine, but they speak words that don't make sense. That's because that connection has been gone. So brain injuries and strokes, things like that can really affect the brain in lots of different ways. But Broca's area, like I said, is one thing that's found in the left frontal lobe. All right, the parietal lobe, okay, so right back here. Okay, it includes the primary sensory cortex, and it basically interprets your sensory information. So basically it takes in your info that you got and processes it all. So look at the primary somatic sensory cortex on page 209. Same idea. It's like you're taking a slice of the brain out, and you're looking at it on here, right? So you got sensory, okay, going on. Genitals, legs, trunk, hip, or head, arm, elbow, forearm, hand, fingers again. Okay, hand and fingers, face, our tongue, right? These are all areas where you need lots of sensory tissue, because those are areas where you receive stimuli. So that's why you'll see those. So these are sensory. Remember, that's receiving information, right? Getting in information. And versus the motor, which was in the frontal lobe, like right in front of the central sulcus. And that's the one that does the movement part, that tells something to me. So pretty crazy and interesting to think about how that works. All right, so occipital lobe, this is the one at the back. Its primary focus is going to be vision. So you get a head injury way at the back of your head, it can affect vision. And then the last one on here is temporal. And lost my spot. These are the lateral lobes, kind of right above your ears. So these are centers for speech, hearing, vision, memory, and emotion. Those are all in that temporal lobe. Speech, hearing, vision, memory, emotion. And again, these are all in your book. It says the region for speech is actually located at the intersection of the occipital lobe, the temporal, and parietal. So it's like right back here, kind of where you would see your speech centers. So again, that's why speech is one thing that a lot of times is really affected with either brain injuries or things like strokes, because there's a lot that goes into making your speech. All right, primary motor cortex and primary somatic sensory cortex we just talked about. Now the internal, the inner part of the cerebrum, okay, so not the cortex, but the inner part is made of myelinated white fiber. So when you look at this section of this brain that I've got here, this is the gray matter along the outside. That's the cortex, like we just talked about, that has all of the motor and sensory information. The white, okay, on the inside, this is myelinated. So remember, it has that little wrapping around it that makes everything move really fast. And then it's got different regions of gray matter in it. You might check in the office. Have you checked in the office? See if somebody's turned it in? They brought me the stuff that was still on the table. You might check in the office. Nayeli and Angelique, I think, were the last ones to go, so you might check up there. Have you checked yet? You might go check it. Because no, they didn't turn anything in. I'm sorry.
Are you recording?
Yes.
Oh. Well, thank you.
Sorry
for interrupting.
No, if it comes up, I'll let you know. Okay. Lost my spot now. Okay, so with inside the white matter is dispersed regions of gray matter, kind of like dispersed inside. These are called basal nuclei, just FYI. All right, next section of the brain. Let me go back to screen here. Okay, you can see the salty bear. All right, the diencephalon. The other name for this, and you need to write this down, is the interbrain. I-N-T-E-R brain. Okay, remember between, kind of like between your brain, right? It's kind of, and it is, it's at the very center. It's kind of hard to actually make a picture of the diencephalon because it's just like right in the middle of the brain. It's kind of an odd place for them to draw a picture to show you where it is. They have a picture of it on 212. So you can look at it there if you want to. All right, so 3 major parts of the diencephalon. We've talked about the hypothalamus before. Hopefully you guys remember. We talked about it because we're talking about temperature regulation. So the diencephalon is located deep inside the brain. The thalamus is just a relay station, right? It's just kind of a go-between. That's relay station for motor and sensory information, and the cerebral cortex, for info and the cerebral cortex. So it sends info to and from the cerebral cortex, right? That motor and sensory information. And then it also helps to regulate the sleep-wake cycle and then consciousness. So at the thalamus, one example is if the thalamus was injured, a coma might be a result of that, right? Unconsciousness. Okay, the hypothalamus is located right below the thalamus. You can, again, picture of it is on page 212. Well, it really just shows the thalamus, so never mind, but it shows kind of part of the diencephalon. Anyways, the hypothalamus regulates metabolism, right? So the rate at which you use up your energy, heart rate, blood pressure, thirst, hunger, energy level, body temperature. This is also the centers for sex, pain, and pleasure. So that's all located in the hypothalamus. Okay? Heart rate, blood pressure, a lot of your involuntary processes are regulated right by your hypothalamus. Hunger, energy level, temperature, again, like we've talked about before. Remember, it works like a thermostat. Okay, and then the last one on here is the epithalamus. And this includes the pineal gland, which produces melatonin. Some of you guys may have taken melatonin before. It's something like a natural hormone that's supposed to help you sleep. So this actually produces melatonin, which tells you, melatonin just kind of tells you that it's time to go to sleep, right? It's something that you have more melatonin levels in your blood in the evening than you do during the day. It's something I used to take with me whenever I would travel, like to Africa, where the time was like opposite, right? Because where I was 9 hours ahead of the time here. So I would take melatonin at the time it was starting to get to be nighttime where I was headed, like in Africa, on, a couple days before I left. And that would kind of get my rhythms going, right? So it wouldn't be such a shock, maybe. Also regulates other sleep cycle hormones. So epithalamus is think sleep. All right, the brain stem, okay, very important part of your brain. This is like regulates your other involuntary processes that you have to have to live, right? It's about the size of your thumb. Okay, there's a picture of it again on 212, shows you the pons, medulla oblongata, and the midbrain. I'm sorry, I see if they're at the top. Midbrain, pons, medulla oblongata. So these are the three sections of your brain stem. Now, midbrain, okay, this is a relay station again, kind of like we talked about with the thalamus, for sensory and motor impulses. So your vision, hearing, motor activity, sleep-wake cycles, alertness, temperature regulation. This is kind of a go-between, right? And you can see it's also connected to the diencephalon, which body temperature and et cetera, all the things we just talked about. Okay, the pons plays a role in the regulation of your breathing. So if the pons were to be damaged, then that's going to play out in not being able to breathe on your own, your body not being able to do that. So brainstem injuries are significant. Okay, the medulla oblongata, look, it regulates heart rate, blood pressure, breathing. It also controls reflexes for coughing, sneezing, or vomiting. You think about coughing, sneezing, and vomiting are all like safety reflexes, basically. Your body tells you to do those things when there's something wrong. So those reflexes are very important. Gag reflex is really important because if you think about it, if you don't gag, the reason you gag, right, or you vomit or gag, is because something is trying to go down that doesn't need to go down, right? It's trying to gets down too far into your trachea. So you're gagging. It's a reflex you need to have. And it's a safety reflex. So that's why it's important. But heart rate, blood pressure, and breathing. When you think about somebody who has a brainstem injury and becoming incapacitated to the point they can't breathe on their own, then that's when they're looking at what do we need to do? Are they going to be in a long-term coma? What's the situation? So brainstem injuries are very serious. And this is why, because these are the things that it regulates. You can understand that. I mean, the midbrain, is a connection point between your brain and your body. So if it's not working, your body's not going to do what your brain is telling it to do. One other part to add in here is the reticular formation. The reticular formation says it extends the length of the brainstem, and it regulates waking from sleep and heightened awareness as well. So it's kind of your awareness. Again, reticular formation damage equals coma. Okay? You're just not waking up from sleeping. All right, one thing that's not in here as well, one other section that is not in here, this page, is your cerebellum, which is a whole nother region of your brain. And there's not a slide in here, so you can write it. I just wrote mine up here at the top. So we'll get to, oh wait, cerebellum, there it is. Yes, you can write this on here, but I wrote mine at the top because I ran out of space. So cerebellum coordinates body movements, increase balance, receives input from your eyes, your inner ears, and we're going to talk about your ears in a few weeks. That's next. That's the next unit we'll get to is sensory. And your inner ears actually is what controls balance. You have these little hairs in your inner ear that have rocks that sit on them. It's really cool. They're called otoliths, those rocks are. And so when you move your head or move your body or spin around, those rocks go with gravity, which makes those hairs move. Well, when that happens, those hairs are connected to sensory receptors in your brain, so they send messages and tell your brain what direction your body's going. Really cool thought, really, it's really cool the way it works. So this is, cerebellum is basically receiving that input and translating it. Sensory receptors continuously monitors body positions and motions. So it works with the inner ear, okay, to know what your body's doing. I read this story. I have this kind of a nursing, it was in one of my nursing classes. And, my early nursing classes. And we read this story. She didn't have what's called proprioception. And it's where you feel where your body parts are. So it wasn't like she was paralyzed, because she could move her arms and legs and everything. She could move everything. But she had to consciously think about moving it and watch it with her eyes. It's like she had lost all ability to feel where, if her eyes were closed, she could not tell you where her legs and arms, what position they were in or where they were. So strange. Anyway, probably some, like a stroke in that particular area of the brain had caused it. But it's just a really weird thought to think about, not having the perception of knowing where your body parts are at any given time. If I close my eyes, I can touch my nose with my eyes closed and my finger, right? I can do the same thing with my eyes or my ears, because I have a sense of where they are. But this particular lady had lost that whole sense, so it's kind of, I don't know, weird, crazy. All right, so let's talk about blood-brain barrier on here real quick. So the blood-brain barrier is just it's not like necessarily a physical, like a big barrier in our brain, but what it means, what it's related to, is that the capillaries in our brain, remember the capillaries are tiny blood vessels, right? That's where gas exchange occurs. They only have like one layer of wall around them, so they're very, very thin, so that nutrients and oxygen can move in and out. Well, the capillaries in the brain are impermeable to most substances, so they won't let stuff in, which is a good thing, right? Because you think about alcohol. Alcohol is one thing that moves past the blood-brain barrier, and so are drugs. But think of other toxic things that we take in, to our system. They don't necessarily always make it to our brain. Water, glucose, and amino acids can pass, right? Our brain needs glucose to work. And alcohol, nicotine, fats, respiratory gases, and anesthetics. So you think that's why they can put you to sleep with those medications, right? The anesthesia medications. A lot of drugs that drugs can do the same thing. But there's a lot of things that can't. A lot of toxins can't get to your brain that might get to your other cells. They can't get through those because the walls on the capillaries in the brain are a lot tougher than other areas of the body. Okay, meninges, which should be right back here behind this. Okay, your meninges, again, are like the protection layer around your brain. Okay, they're located between your skull and your brain itself. And there's 3 different ones. So the dura mater literally means tough mother, okay, or hard mother. It's a double layered membrane, kind of wraps in and on itself. Okay, so it's double layered, very, very tough. This also covers the spinal cord. Okay, the dura mater. Mater is the layer. Okay. Arachnoid mater, can't talk, is web-like. Okay, so you can kind of see it in here. See this little, it's got kind of all of these little spider web looking things. Makes sense. Like arachnophobia, right? Arachnoids are your spiders. So spider web kind of has that look. So there's actually a space between the arachnoid mater and the pia mater, which is underneath that. And that space holds all of the cerebrospinal fluid. Cerebro means brain, right? Like cerebrum. And so it actually holds cerebrospinal fluid, which helps to cushion the brain, provides nutrients, but it really cushions the brain. It provides another safety net for the brain. And then the pia mater is the innermost part of the brain, or innermost layer of the brain, right? It's the deepest layer. It attaches directly to the surface of the brain and the spinal cord. And the term for this is a gentle mother. Mater is, I guess, root word is mother, right? It's protecting the brain. Makes sense. We got tough mother, spider mother, and gentle mother. But those are the layers. Okay, pia mater is attached directly to the brain. I think that you'll be able to, if I remember correctly from before when we have dissected the brain, I think you could still see some of the arachnoid mater for sure. And then the pia mater is kind of hard to tell because it's just attached to the brain. It doesn't really just come off. All right, spinal cord. Okay, so this is a picture of the spinal cord. I was thinking I had a picture of the spinal cord, but maybe I don't. Anyway, so the spinal cord, okay, obviously it's a major relaying pathway, right? And it also has reflex arcs, which we're about to talk about. But it's also covered by the 3 meninges. So look, you can see the dura mater, arachnoid mater, and then the pia mater that just goes right around the outside of the spinal cord. Okay, the cord, the exterior part of the cord, is myelinated white matter. Okay, so everybody see the white matter? It's kind of opposite of the brain, of the cerebrum, right? The cerebrum had gray matter on the outside, white matter on the inside. Spinal cord, white matter on the outside, gray matter on the inside. So the white matter is myelinated. Remember, it's got that myelin sheath around it. The interior part, this butterfly-shaped part, okay, of the spinal cord. This picture is basically what they've done is chopped up the spinal cord, and then you're looking at it from the top. I actually have a microscope slide. I'll see if I can get it out, and I'll leave it out for you guys. If you have a chance today after this, I want you guys to look at it. If not, I'll put it on there for Monday or something. Or tomorrow. Maybe you guys can look at it tomorrow if you need to. So, The interior part, the gray matter, is mostly cell bodies and interneurons. And cell bodies and interneurons. Interneurons are between, like we talked about with the reflexes and things like that. All right, dorsal white matter says carries sensory info to the brain. Dorsal white matter. So central canal runs right through the center. I'm going to say this side right here is anterior. This back here is posterior. So this posterior, okay, would be dorsal. So the dorsal white matter, so this section back here, okay, carries sensory information to the brain. So it's going to send information that's going from the sensory neurons, like from the hands and toes, whatever, back up towards the brain. Okay, that's where those axons are located. Lateral and ventral. Okay, so lateral, this is why we learned all those terms at the beginning of the year. Lateral is on the sides, remember, ventral is in the front. Okay, so these two transmit both sensory and motor impulses. Both sensory and motor impulses. Okay. So remember, motor is sending it back out to the body, away from the central nervous system. So that's what you see there. Oh, one more thing to add to your notes. Cerebrospinal fluid is formed by what's called the choroid plexus. C-H-O-R-O-I-D, plexus, P-L-E-X-U-S. Okay, that's a part of the brain that forms cerebrospinal fluid, or CSF. You hear me say CSF, that's what I'm talking about, cerebrospinal fluid. I hadn't really thought much about the choroid plexus until a couple years ago when I was pregnant with Micah. I got a call, I was actually at school. I think we were probably learning about the nervous system because it was about the same time of the year. And she said that on the sonogram, they had found some choroid plexus cysts in Micah's brain. And that's what they had seen on the sonogram, which of course concerned me. She said it was probably fine, but they were going to do a repeat sonogram, and it turned out to be nothing. But that's what it was when the choroid plexus of his brain was being formed. It just, part of it kind of pinched off and made a little blistery cyst, and it just dissipated and went away. But pretty, I don't know, you think about things you don't ever know about, and all of a sudden they get really real. But that was choroid plexus. And I think that is it. So you guys can answer these questions if you want to. But that's it. We will continue on next week. Tuesday we will dissect the brains. So that's always fun. I think you'll enjoy that. And I guess that's it. You guys keep working on your chapter packets.